All right, so day one. First thing we're going to do is we're going to go over a few vocab words. We're going to do a little bit of work. Yes, I want you to try to do it without a calculator. We're going to see how much mathematical stuff we can do in those brains of ours. So a mathematical quantity is anything that can be measured or counted. Some quantities remain constant. For example, 4 is a quantity that remains constant. It is always going to be a 4. Others change or vary and are called variable quantities. Those ones aren't always the same. Most times our variable quantities are represented by letters, like X, A, Y, Z. You could use symbols. I think it would be awesome if math just all of a sudden starts like putting smiley faces and stars everywhere instead of letters, but nobody jumped on board with that for me. So down here, a blank blank is a mathematical phrase involving numbers and operations, but no variables. That would be a numerical expression. As you can see with that word numerical, it starts out like a number. So that's how you know it's a numerical expression, purely numbers, no letters. You can add them, subtract them, multiply, and divide them. That term simplify there, that is a very important one because a lot of people get simplified confused with evaluating and solving. They're not actually the same thing. You simplify a numerical expression when you replace it with its single numerical value. So for example, simplest form of 2 times 8 is 16. So you simplified it by turning it into a 16. That's what our simplifying is. A power has 2 parts, a base and an exponent. The exponent tells you how many times to use the base as a factor, so it's how many times you multiply the base. So if you have an exponent of 4, that means you're multiplying that number 4 times. And I got a couple of notes here. First one, be careful when you're simplifying your powers. Parentheses always make a big deal. And a lot of kids like to tell me, oh, it's not a big deal. It really is a big deal. So parentheses -3 squared versus -3 squared without any parentheses. It's always going to be a big deal. Because of these parentheses here, that means it's -3 times -3. The negative is part of what's being squared. So therefore, -3 times -3 gives us a +9. However, if you do not have parentheses, so like for example this one, there's no parentheses there, it's just negative is chilling out in front, and then you've got the 3 that is squared. I always say negative there, that's kind of like your little sibling that you have to bring with you to the store, but you don't really want them to be there. So you say, stay here in the front. You just stay there, I'll be right back. So your little sibling hangs out in the front there because there's no parentheses. So they are not attached to you. They are supposed to be staying right there. And then you take your 3 and you square it. So that means you're multiplying your 3 twice. So 3 times 3 is still 9, but your sibling is still sitting in the front of the store. And you gotta make sure you bring him home or her home, otherwise mom and dad are going to kill you. My brothers made that mistake once. You make sure your little sibling comes home with you, so they still have to be there. So that's why that turns into -9. That negative is not actually squared. It's not attached to you. You told them to wait there. You went, you did your business. You gotta make sure they come home with you. They're still there. And then my other note here, anything to the 0 power equals a what? 1. Anything to the 0 power is a 1. Everything to the 0 power is a 1. Again, the other thing to be careful of though, for example, I have 3x to the 0. What is the exponent attached to? X. Is it attached to the 3? No. Is it now attached to the 3? Yes, because of the parentheses. Parentheses means it's attached. So this whole thing would turn into a 1. This whole thing would end up turning into 3 times 1 because only your x turns into a 1. So it ends up being a 3 for that. So you got to pay attention. Parentheses make a big deal. Details, details, details. All right, so order of operations. A lot of you remember them. What are our order of operations? P stands for parentheses, exponents, multiply, divide, and then add, subtract. But see, there's some things that they leave out with PEMDAS. I don't really like calling it PEMDAS. So parentheses, yes, parentheses. You know your traditional parentheses. But there are 2 other things that fall within that parentheses category. Brackets are considered parentheses. So if you have brackets within a problem, it happens first, just like your parentheses do. And then the other things are your absolute value bars. You guys remember what absolute value does? Turns everything positive. Absolute value turns everything positive. So it was already positive, stays positive. If it was negative, it turns positive. So parentheses, brackets, and absolute value bars, those all happen at the same time. That is always your first step. My slight issue with exponents is it's really exponents and roots. Roots meaning, for example, square root. So like if you're trying to take the square root of 25, that would happen at the same time as an exponent would. So it's really exponents and roots. And then I don't have too many problems with multiply, divide, add, subtract. You just have to remember, you go from left to right, just like you're reading a book. Left to right, whichever one you see first is the one that you do first. So let's take a look at our 2 examples here. Number 1's kind of a big, huge, long mess there, so it's always good to take a second, look at what we have. This one has brackets and it has parentheses. So which one do we do first? Yeah. The parentheses. You always go in the middle first. So 3 minus 1 makes that a 2. And then everything else stays the way it is. So now I still have those brackets there, so I still have to keep doing what's inside the brackets first. So within the brackets, what do we do first? The exponent. So 2 to the 3rd is 8. I don't feel like writing it again, so I'm going to cheat and just cross it out and make that an 8. So now I can add. What's 6 plus 8? 14. So everything in my bracket simplifies down into a 14. 2 times 2 is 4, times 2 more is 8. You're thinking of 2 times 3. So now, what would we do next? Yep. Yep, you multiply here. Remember, 2 things next to each other like that. That means they're being multiplied. Anybody multiply with a fraction in their head? It does end up being 4, yeah. 28 over 7. Yep, you're really close though. 28 over 7, that was good, which simplifies to a 4. Fractions are our friends. That's why they both start with FR. Fractions are friends. You're going to see a lot of fractions throughout the year. New York State Regents prefers fractions over decimals, so you got to get in the habit of using those fractions. All right, so what's our final answer here? 9. So next to number 2, I kind of wrote a little strategy to help you while you're working on your homework. When starting a new problem, especially if it's one you're struggling with, try to compare it and contrast it to one that you knew how to do, and that might make things a little bit easier for you. Comparing number 2 to number 1, though, they don't really have much in common except that they have numbers and there's some parentheses there. But what does this line right here tell us? We're going to divide. When would we actually divide, though? At the very end. Good. So what we're going to want to do is we're going to want to simplify everything in the top using our order of operations, simplify everything in the denominator using our order of operations, and then divide your two answers. So looking at our numerator, what do we do first? Yeah. Add your 3 and your 1, so that gives me a 4. So 7 times 4, 28. So what does that give us in our numerator? 28 minus 2 is 26. So numerator, check, 26. Denominator, what do we want to do first? Yeah. So 5 times 2 gives me a 10. 10 plus 3 gives us 13. So divide them and we get 2. Our final answer there is 2. Yes, ma'am? No. Taking a look at the back there. So we were just dealing with our numerical expressions. Those ones were purely numbers, add, subtract, multiply, divide. So an algebraic expression is one that includes letters, your variables there. Numerical, purely numbers, algebraic, letters. So a variable is a symbol, which we usually use letters just because it's faster to write, which represents a value or values of a varying quantity. So it just represents some value we don't know. And we usually, X is our most common one, but as you'll see throughout the year, I'm going to try to use different letters because on the Regents exam they like to use different letters. Also on the Regents they like to tell you what specific letter to use, so you have to make sure you pay attention to that detail also. In an algebraic expression, a blank can be a number, variable, or the product of a number and one or more variables, and that would be a term. So for example, the number 4 can be a term all by itself. The letter A can be a term all by itself, or some kind of combination of one or more. So like 7xy is also a term. It's just one single value, no pluses, no minuses. That is a term. So a coefficient is a numerical factor of a term, and it is written in front of the variable. That's usually your first thing there is your coefficient. Everything has a coefficient. We just don't always write which number. We don't write the number 1. So for example, if I have x, it actually has a coefficient. It has a coefficient of 1. We don't always write those ones because we get a little bit lazy. So let's look at my term that I have here, my 3x squared. Of that, what part of that is our coefficient? The 3. Our base is what has the exponent attached to it, so that is our x. And then our exponent would be 2. So those are our 3 parts to our expression there, our term there. So now, evaluating, as I said before, it's something that people get confused a lot of times with simplify. To evaluate an expression means that you take a number and you plug it into a letter. That's the actual process of evaluating, and then you simplify it down to a single term. So you actually have to do the two of them together. So here's my example. So you're given an expression, and then you're given a number to plug in for the letter, and then we got to simplify it. So whenever I'm doing evaluating, I always tell students to first set up the problem, and anywhere you see the variable, put in a set of parentheses instead. So we got x squared, so I'm going to start off with parentheses squared minus 5 times parentheses plus 4. For problems like this, you probably don't need it, but stuff we're going to be doing in like February and March, this skill is going to be very useful, so it's good to practice it on the easier ones. And when we get to the more complicated stuff, it's kind of like ingrained in your brain. So I first set up my parentheses, and then I go and I plug in my number. So they told me to use 7 for x, so then I go and I plug in my 7. So that is our evaluating process, plugging that number in. Now we're going to simplify it. So order of operations, what do we want to do first? Yeah. So we want to do our parentheses first. This one's telling us to square it, so 7 squared, 49. Multiply those ones, negative 5 times 7, 35. So now we got to work our way left to right. So 49 minus 35, 14. And then plus our 4 gives us 18. So looking at number 2, we've got 2 letters in there. We got an R and an S. So again, first thing I'm going to do is everywhere I see a letter, I'm going to set up parentheses. Notice my negative sign is in front of my parentheses because it's just in front of the R. Your little sibling sitting in the front of the store waiting for you to go home. So now we plug in. For R, we're going to put in negative 3. And then for S, we're going to put in a 9. So again, this right here, this is our square root, so that's going to happen at the same time as our exponents. So negative 3 squared means it's negative 3 times negative 3. So that becomes positive 9. But you got your little sister at the store, so she's got to come down too. She's got to make it home. Square root of 9? 3. When you take the square root sign, or when you take the square root of it, the sign is gone. You've used it, so you're not going to keep writing that little square root sign there. So now negative 9 times 3 will give us a negative 27 for that one. So what I want you to do, take a minute, try number 3 and 4 on your own. Set up the parentheses. On number 4, when you get to it, those are absolute value signs. I tend to overemphasize them when I draw them. And then with number 4, the absolute value is like a parenthesis, so you got to take care of that stuff first. So my negative 5 times 2 gives me a negative 10 when I multiply those. So then absolute value of 10 turns that to be positive, so we end up with 3 times 10 there. Minus the absolute value of negative 1 just becomes 1. But it is negative because you got that subtraction sign right here. So 3 times 10 gives me a 30. Minus 1 gives us a 29 for that one.